You got this. Let's learn some math. First problem that we have for lesson 1.1.3 is review and preview. And so I'm going to kind of go over these little answers and then move on to the next problem. This one says you have g of x graphed at the right, which is right here, and which x values have points on the graph. That is, describe the domain. Well, my first thing is to look for the lowest x value. Well, that's -2. So I'm going to go ahead and put -2 here. Then I'm going to look for the highest x value. Well, that just happens to be at 4. So that means that my domain is between -2 and 4. But one thing I need to do here to make it totally correct, because these points are solid, is that I have to say -2 is less than or equal to x, which is less than or equal to 4. That's my domain. So that answers the domain for that particular problem. So let's erase these marks here, because now we're going to talk about the range. Okay, so on the range, let's use a different color because I like to use different colors. On the range, we're looking at the y values. Well, my y value, kind of hard to see here, but if you look at your homework, you can also see it. But -1 is my lowest y value, okay? And my highest y value is 3. So in the same theme as the first one, we're going to put -1 as my lowest, and then it's less than or equal to, because it's solid, to y, which is less than or equal to 3. And that helps you answer those questions. Now, I like what Ricky's thinking on this part C, but he is incorrect, and I'll show you why. So he has g of x is -1. So he's showing us that the y value is, we have a -1 here, and we have a -1 here. He's talking about 0 also, which we have a 0 and a 0 and a 0. And we have a 1 and a 1 and a 1. And then we also have 2 and 2 and 2 and 3. The problem is he's missing every single point in between, and that's an infinite number of points. So that is why it is -1 to 3 inclusively, because you still have the square root of 3 in there. You have -1 point, wait, I can't do that one because that's out of the range. But I could say -0.0833. I could say 2.234. I mean, I'm just giving you numbers. He's missing all of the fractions and all the irrational numbers. So all rational and irrational numbers in between -1 and 3 if he's just going to list integers. So integers is not the answer for this. It's all real numbers between -1 and 3. All real numbers. Okay. So on this last one, it's kind of fun. You can sit there and say, draw a graph for another function with the same domain and range as g of x. Well, I could do all kinds of things. I could start up at 3 and go down to -1 and go back up to 3 and down to 2. And they've got the domain as 4, so I could still continue on and go to 4. I could do all kinds of things as long as it passes a vertical line test. And when I say a vertical line test, which I've talked about in quite a few of my videos, it's as long as every x value only has one y value. So if I could sit here and draw, let me get a line for you, a line, and I do a vertical line here. Let's do another one. I'm going to go back to my shapes. Get another one here. As long as I'm drawing through and it's only hitting the graph at one point, then I am coming up with a function. And some of you could probably have much more creative functions. But that ends the discussion, all of the parts of 1-34. So this particular problem is 1-35, and I'm going to be doing this in two parts. One is going to be Desmos, and then the second is going to be a slide that covers it. So for the Desmos activity, I'm going to actually be answering A through D and then talking about I. E through H we will do on another slide. So what I want to start by doing, because the easiest way to do this when you have a graphing calculator is to go ahead and create a table. So I'm going to go ahead and create a table. If you hear some weird noises, my dog is sitting right next to me, so he just grumbled. So sorry about that. That's what happens when you're at home. I think I've said that on another video. I'll probably say it many more times. So anyway, I'm going to put a table in. And right now it's got values in there that I don't want. So I'm going to get rid of those because we're looking for two specific values. What they've asked us to find is f of 5. So I'm going to put 5 as my input, and that gives us 70. And we'll look at that in a moment. Then also f of 4, which gives me 43, which makes sense. If you're to plug these values in, if I put in 5 in here, it'd be 5 squared, which would be 75. 5 squared would be 25. 3 times 25 is 75. 75 minus 5 is 70. So that makes sense. Same thing here. If I put the 4 in, 4 squared is 16. 3 times 16 is 48. 48 minus 5 is 43. You can verify all of that on a calculator if you want. But right now what I'm doing is I'm going to show you, I can't see those points right now, but I'm going to go all the way up here. You're going to see our f of 4 first, plotted here at 43, and you're going to see our f of 5 at 70. So that gives you an idea what those values are. So you can plug those in, substitute them into the equation, or you can look at a graphing calculator and go find those points by using tables as well. So I'm going to use a table on the second one as well. So I'm going to hit here and I'm going to go and ask for a table. Perfect. And I'm going to delete everything here again. Talk about all those undefined terms in a moment. And then I'm going to type in g of 5 because that was one value they wanted, and and g of 4. Okay. All right. So this is interesting. G of 5 gives me a 2. Makes sense. If I put a 5 in here, 5 minus 5 is 0. Square root of 0 plus 2 equals 2. This is undefined. And part of the reason for that is if I plug 4 in here, 4 minus 5 is going to give me a negative 1. Can't do the square root of negative 1 because right now we're just working with real numbers, not imaginary numbers. So therefore, it's considered undefined. And that would be true of any domain value that is to the left of this 5, 2. 5, 2 is the starting point. So let's talk about that here. It says, why is the domain of one of these functions more restrictive than the other? Well, let's go up here and look at this other equation. There's not a single value that you could put in this f of x function that wouldn't work. Every value will work. So therefore, the domain, even though you can't really see it here, the domain of a quadratic is all real numbers. So you can go all the way to the left and all the way to the right. So all the way to negative infinity and all the way to the right to positive infinity. The difference here in the g of x function is that we have to limit our numbers so that there's no negative in our radical when we start it. That is why 5 works. 5 minus 5 is the lowest you could have because that would be 0. You can do the square root of 0. You can't do the square root of a negative because we're not working with imaginary numbers. So therefore your domain starts at 5 and it includes 5 because you see this solid point here. If this was open, it would mean it didn't include it. But this is a solid point and it goes from positive 5 to positive infinity, and that's the domain for that particular function. But that's why there's restrictions. We can't go anything less than 5 or we'll have an imaginary number. Hopefully that helps. Okay, so we just finished the first part. Well, it's actually half of the 1-35. Here's the second half of it. And it's just easier to actually talk about these rather than do these in Desmos. So all you're doing here is adding these two functions together on part E. And so literally you're going to substitute in the function for each of those. So instead of f of x, I'm going to write 3x squared minus 5 plus, and then I'm going to, instead of g of x, I'm going to write the function for it, which is the square root of x minus 5 plus 2. Then all I'm doing on this is combining like terms, because this particular one is all by itself. There's really nothing you can do with that. So your final answer on this one is going to be 3x squared plus square root of x minus 5, and then you're combining that negative 5 and that positive 2, so it's minus 3. And that is f of x plus g of x. Okay, next one is the opposite. It's subtraction, and they've got the functions in a different order. So again, we're still going to substitute, and we're going to put g of x function in, so that's the square root of x minus 5 plus 2. Now, I'm putting a subtraction in, but I'm also then going to put parentheses because I have to remember to distribute this negative, okay? And a lot of times that is the common mistake that people make. So I'm going to put in 3x squared minus 5. Now, I'm going to go ahead and erase this word here so we have some room to write the results. So I come down here. I'm going to first just distribute my negative so I know what I have. And when I say distributed my negative, it means I'm going to put it on the 3x squared and the negative 5. So that means it's minus 3x squared plus 5. And then I'm just going to rewrite the answer. And I always like to lead with my term that's got the highest exponent because that's kind of considered standard form. So I'm going to go ahead and write negative 3x squared and then plus square root of x minus 5. And then again, I'm combining the 2 and the 7, so plus 7. So you've got your answer here for the first part and here for the second part. And they're very different looking. Now, it also wants us to talk about the domain of x, of f of x. F of x is right here. It's a parabola. It is a quadratic, and all quadratics and parabolas have the same domain. Every x value is possible. You may not see every x value get hit, but all the way to negative infinity and to positive infinity on the x. Those are terrible arrows, by the way. Sorry about that. So your answer would be at this point, all the way negative infinity, and then x is less than positive infinity. And you could say equals negative infinity, but you never get there, so it really doesn't. So again, I've shown you different notations too. So if I go back and do interval notation, you might also see this as negative infinity to positive infinity with parentheses. But this is the way that CPM denotes domain. So that will help you, at least when it's all real numbers. Okay, and then describe the range of g of x. This is h. The range on this one is not going to be all real numbers. And if you think about it, look at where it starts. Our range starts at 5. And we've already talked about everything that is to the left. Let me use a little different color here. Everything to the left is undefined for g of x. So it's just going to start, and so this is a coordinate. This is 5 on the x and 2 on the y. So that means we are going to have a range that goes from 2 to positive infinity because this continues going on forever. So the range here would be y is greater than or equal to 2. Here we go, and that ends our discussion for 1-35. Moving on. Okay, so in this particular problem on 1-36, there are two students arguing over whether or not the math problem has been done correctly. Chalita is confident that she has done it correctly, and she has for most of the part of what she's thinking. Her logic is correct, but her factoring is not correct. And Nisos realizes that. So the getting from here to here is inaccurate. So I'm going to do the diamond method, which I've done on a couple other videos, but let's just refresh a bit. We are looking at the standard form of the equation as ax squared plus bx plus c. That means on this equation, a equals 1, b equals negative 10, and c equals a positive 21. And so what I want to put in this top square, top square, is a times c. So in this case, it would be 21. And down here is b, and that would be negative 10. So I'm trying to find two numbers that multiply to 21 and add up to a -10. Now, the first thing I would think is 3 and 7. And I'll put those in those side boxes. 3 times 7 does equal 21, but 3 plus 7 does not equal -10. So I need to make both of these negative. So that means my factoring would look like this. X minus 3 and X minus 7. And you notice she's put the pluses in. Now, her next step where she said X minus 3 equals 0 and X minus 7 is equal to 0, that is correct. Setting it equal to 0 is what helps you solve it. But in this case, that means X equals 3 or X equals 7. That's the correct work. And hope that helps. And that ends our discussion about 1-36. We are moving on. Okay, so on 1-37 here, there's a couple things that I want to talk about before I show you this video that's going to really help. All I did was basic algebra on all of these problems. So you'll see right here, I just got everything to, sorry, I was in the wrong mode. There we go. So you see, I just subtracted 6 and divided by 3. Now, I have 1/3 x here, but x over 3 is the same thing. So if you solved it like that, you could also have x over 5 here. But I just basically got everything into y equals form so I could put them into this Desmos activity and show you the differences of different equations. Hopefully that helps. Remember, you can always put questions for me in the comments of the video, and I will get back if you need clarification. I am here to help in any way I can. So let's move on and show you the video. Okay, here we are at number 1-37. And you've had 5 equations that we have on the left that have been taken from the original given format and turned into a y equals format. And now we're going to actually plug those into the graphing calculator and prove that the work we did was correct. And then there's a couple that I want to talk a little bit more about. So let's just start with A. And we'll come here and we'll make sure that this particular equation goes live. And right now we've got this equation, but that's not doing anything yet. So we're going to go in here and delete all of these and put the equation that we came up with, which was 1/3. And you got to move it a little bit to the right here, x minus 2. And what you see here is these lines are now coinciding. So that helps us understand a little bit more about what's happening here. So let's go and look at the rest of these. So now that we have finished part A, let's look at the rest of them. So I'm going to go ahead and mute these. And let's look at B. The first equation we have is what they gave us. So let's go ahead and unmute that so you can see what it looks like. You'll see that I put this into y equals, which you can actually see the work, like I said, to the left of this video. And as I hit this to make it go live, it will coincide with the original. And you can see that. So even if I change the color here, which would probably help you, let me go in here and see if I can get that changed really quick. There we go. Let's change it to green, and you'll see that it's the same over the top of it. So that proves that they are equivalent. Let's mute those now and move on to C. Okay, so here's C. C has two terms, or two y's, so like y is squared. So there's going to be two equations. And when you solve that, you're going to see it's a horizontal parabola, which if I use my slider, which I have here, I've been talking recently about vertical line tests where it proves that every x has one y when it has a function, when it is a function. So if I go through here, you can see if we're looking purely at the x equals y squared term, that is not a function. And that is because you see here, just as an example, this 3 for x has a y value up here and a y value down here. Therefore, that proves that that is not a function. Now, when you break it down and do the solving, you will get y equals plus or minus the square root of x. In a calculator, you can put them in, but you have to do two different lines. So here's the first one. And let me change that to purple. Okay, so here's the first one, and you can see how it's going over the top half. That itself is a function by itself. And then we have the second one. Let's change this one to red. Okay, and you can see this is the second one. This is y equals the negative square root of x. Separately, those are two functions. But if I mute these, you still see this one as x equals y squared. This is something that you would know later as a conic. You have not learned that yet and will not learn it for a while. But this horizontal parabola is not a function. So anytime the y term is squared, you will find that even if you set it equal to y equals, you're going to have two equations to draw the graph of the original, but they are not functions. Separately they are, but together they are not. So you see off to the left here, I have y equals plus or minus the square root of x. That is two equations, and we have two others that are just like that. So let's go ahead and mute that, and we'll go check out the next one. So here's D. D is similar. You have a y squared term. So by the time you add 4, divide by 2, and take the square root, this is what the graph would look like. Now, I'm going to go ahead and change the colors of these two because this will show it. These are two separate equations again. And if you look at the information on the left under D, you will see two equations. It's a plus or a minus. Each one stands for one equation. So I'm going to go like this. I'm going to change the color. So it's drastically different. Oh, I can't believe I just went with a husky color. Anyway, sorry, go Cougs. Okay, so you see here, this is the purple. This is the top half. So this by itself is a function. And if I use that slider and go back and forth, you'll see that my vertical line hits that purple equation only at one spot. But if I unmute this, or if I mute this, I mean, and I'm just looking at the orange colored one, this is not a function. Again, the y term is squared, so it's not a function. These separately, if I mute this and I pick this one, that is a function. I will mute this and then unmute this, and that is a function. But together they are not a function. But if you're trying to put that whole graph in, that is how you would do it. So this kind of shows you another example of a y term being squared where it is not a function, but you still could draw it. You just have to do two different functions to draw it. So let's mute those and move on to our last one. Here is E. Again, it looks a little different, and you don't have to FOIL this out and multiply it out to get the y term squared. The y term is just squared just because this exponent is out here. But let's look at what this looks like again. It's a horizontal parabola again. And when you solve it algebraically, you get y equals plus or minus the square root of x plus 5. So let's go down here, and I'm going to just mute this one. We're going to talk about them one at a time. Well, let's unmute that first. Right here you see, not a function. Vertical line goes through two spots of it, hits multiple x's have two y's, and that's not possible for a function in the definition of a function. So we'll mute this. Here's the top half, or I'm sorry, the bottom half. I forgot to put the negative first. This is the bottom half. This would be a function by itself. And then this would also be a function by itself, but together they are not. So hopefully that helps you understand a little bit more about what we're doing and this vertical line test, which is hugely helpful in determining if certain graphs are functions. We will now mute all of these, and we are done. Let's now move on to 1-38. So this is number 138, and I know some of you are going, why lime green and blue? Well, you know, it is football season. I do have a fantasy team. I like lime green. It's my favorite color. Plus, it gets really boring if I always use the same colors. So it's a little different, but hopefully you don't mind. Okay, so what I want to go ahead and do right now is just talk about A and B and solve those, and then I'll put a picture of the graph on, and then we'll talk about what these two mean. If I'm asked to find out what F, and it should say compute, not computer. I teach computer science, so I got a little bit distracted. Okay, so F of 0 means I'm going to plug in 0 for my X. So that's going to be F of 0 equals -7. Okay, we'll talk about what that means in a moment. Most of you probably already have figured it out because you are in Algebra 2. Now it says solve f of x equals 0. So instead of putting something in for the x, I'm actually going to set 2x minus 7 equal to 0. So I'm going to add 7 and divide by 2. Okay. Now, for the graph, let's put that graph there and you'll see what these are. This, hopefully you have figured out, is our y-intercept. But you should know that just because the original was already in slope-intercept form. So that's your y-intercept. So this point is 3.50. So that's your x-intercept. This would be a coordinate of 0, -7. Y-intercept. So let's take a look at a picture of the graph of this and you'll have a better idea of what I'm talking about. This is a picture of the graph. So if I'm looking for my y-intercept, let's get a different color here. Oh, we got to get one that shows up. Okay, red will show up. My y-intercept should be at 0, -7, which we have up here, and that's what this is. So the f of 0 gives us our y-intercept. Now setting the equation equal to 0 gives us our x-intercept. Or in the world of quadratics, if it was crossing the x-axis, we would call it one of our solutions. But we've set it equal, so this is at 3.50. So that's what those are. That's how they're important to this graph. One is the y-intercept and the other is the x-intercept. And that ends 138. Let's move on. Okay, so I love these Desmos activities that CPM puts in. So you can actually go in and manipulate in Desmos online and help answer the questions that you need to. So let's read through this question really quick. It says, Gregory planted a lemon tree in his backyard. When he planted the tree, it was 2 feet tall. He noticed it had been growing 3 inches every week. They want us to create multiple representations, so an XY table, a graph, and an equation, to represent the relationship between the days that have passed and the height of the tree. So what I'm going to do, I like to work with graphs that help me, and that means I set some parameters at the beginning, I set my scale, I label it, all of those things so that it's easier to see my solutions. So what I'm going to do first is I'm going to start by changing, because we don't really need the negative parts of the axis. So we don't need quadrant 2 and quadrant 4. So I'm going to come in here and I'm going to say -5. And I don't care what happens with the ending of the graph. It's more limiting the view of at the start of the negative parts of the graph. So I like to set -5 here. Oops, I don't want a -5, just -5. And then I want steps of 1 for both, because I like it when it's easy to read. And then I've got the x-axis. And on the x-axis, I am going to put time, and that's in weeks. And so if you look at your graphing calculator, the Texas Instrument, if you have one of those, you will see that the particular button that you choose to put the x variable in also has a little t on it. T is time, and time is typically an independent variable because that's what happens and determines your dependent variable at the end. And so our dependent variable on this one is height, and it's in inches. All right, so if you notice here, we have a couple of things that are kind of cool. We have our labels on the graph, okay? And I can move out of the picture, and notice if I move out of the picture, time in weeks still comes up. And if I go here, height in inches still goes up. It's kind of cool. All right, now we know at 0, so I'm going to go and put some values in the table. At 0 weeks, the plant was planted and it was 24 inches tall. Okay, and Gregory says that it grows 3 inches each week. So let's put a 1 in, and that would be 27. Then we're going to put a 2 in, and that would be 30. If you get the idea, our slope here is 3 because we keep going up 3. So 3 weeks, it's going to be 33. 4 weeks, it's going to be 36. And 5 weeks, it's going to be 39. Okay. Now, you can't see any of those points right now. And the reason you can't is our y-intercept is at 24. So we're going to scroll up here and we'll be able to see our points. So here's our y-intercept. Notice it goes up 3 over 1 each time. You notice you can still see the x-axis numbers down here, so it's easier to follow. So my equation, I've got a slope of 3, so that means it's going to be y equals 3x, and we're starting at 24 inches, so it's going to be plus 24. All right, and you can see that right here. Now, the question that we have, so there's 3 representations. You've got your XY table, you've got your rule that you came up with, and you have your linear graph. Now, down here it says, if the tree continues growing at this rate, when will it be 6 feet tall? How can you see this in each of the representations? Well, I can go ahead and divide 6, or actually multiply 6 by 12, which gives me 72. 72 inches is how much it takes to get to 6 feet. So what I'm going to do is I'm going to actually look at height in inches, and I'm going to go up to 72. And yes, it's quite a trip, but it is right here. So I go over here to the graph, and you can do this on your Texas Instrument as well, probably easier to find. And then you're going to go down here to the line where it intersects. Well, it says it's at 16 weeks. So I'm going to go ahead and put in a point in our table. And I'm going to put 16. And once I hit 72, we should have a point there, and it should be on our line. So let's go here and put 72. Notice we have it, and it's actually on our line with the rest of the points that we did earlier in the graph. Okay, now let's talk about this is part C, the inputs and the outputs. The inputs are purely the number of weeks, and we can go on into infinity. I don't think we're gonna, but we can, it's just the number of weeks for the particular problem. So if you have, where is it going to be at 10 weeks? Where is it going to be at 100 weeks? So that is the input. Now all of the outputs will be the dependent variable, and those are going to be the heights of the tree in inches. And you can do that all the way up the line and look for it. Now, if you've got time in your day, you could keep going. You could move it over and you can find more stuff. So, but we're not going to do that. We have already answered all of the lovely questions for this problem. And so you are probably good. I want to get back down to the point of origin. It's just something for me. Okay, there you go. Don't forget my little help with the wrench. You can sit there and play with that. And that ends our discussion about 1-39. Hope it helps, and we're moving on. Okay, so this is our last problem for this particular assignment. And I like these kinds of problems because they help me highlight a few mistakes that people commonly make. And we want to make sure you guys are not only doing order of operations, but you're also distributing negatives. And those are mistakes. It doesn't matter what level of math you are in. People make those mistakes. So we are going to help you with that right now. So I'm just going to go ahead and walk through how I do it. All right. First thing I'm going to do is multiply. I'm going to distribute my 4. So that's going to give me, let me get my pen going here. Okay, just 1 second. There we go. Okay. So 4x minus 4 minus 6x, because we want to make sure we distribute to here. We can also take that negative here. So negative 2 times 5 is minus 10. So negative 10 equals negative 3x minus 1. The next step we're going to do is combine like terms, which I can denote with a CLT. And that's going to give me a 4x and a negative 6x, negative 2x. Negative 4 minus 10 is negative 14 equals negative 3x minus 1. Now, what I really like to do is avoid negatives. So I'm going to add 3x. And because you're Algebra 2, I'm going to do this both at the same time. So hopefully you're understanding what I'm saying. So I'm going to add 3x and I'm going to add 14. So if I add 3x, I get x. And if I add 14, I get 13 because we have it to a negative 1. Now, the next thing it says, though, is to make sure we check our work. So I'm going to plug in, and it always drives me crazy when something says check work and people don't check their work because you can often find lots of mistakes that way. So I'm going to put in 13 minus 1 minus 2, and I'm going to do 3 times 13 plus 5. And I'm hoping it all works. I'm going to do negative 3 times 13 minus 1. All right. 4 times 12 is what we would have here. Then we would have inside the parentheses, we would have 3 times 13, which is 39, plus 5 is 44. And then on the other side, we're going to do negative 3 times 13, which is a negative 39, minus 1. So it's supposed to all equal negative 40. So we'll find out here. So this is 48. And then negative 2 times 44 is a negative 88. Well, we did it right because 48 minus 88 is a negative 40 equals negative 40. So those check. So awesome. We did a good job on that one. Now we're going to come over here and do part B. And I'm going to get a different color just because I like to do that. So hang on a second. If it lets me, come on. Oh, well. Are you not going to let me? Okay, thank you. I want just a different color. All right. So now what I'm going to do is the same thing. 3x minus 5 equals 2.5x plus 3 minus x minus 4. Now, to do that, I'm going to go ahead and distribute what I can distribute. And the only thing I really need to distribute here is this negative. So equals 2.5x plus 3. Well, it's got to be minus x. And then because it's a negative, it's going to be plus 4. So on the right-hand side, I need to combine like terms. Well, we got 2.5x minus x, so that's going to be 1.5x. And we have 3 plus 4, so that's 7. Then on the other side, we have 3x minus 5. At this point, I'm going to go ahead and I'm going to change the 1.5x because that's what I like to do. I don't like to work with decimals when I'm doing algebra. So I'm going to change it to 3 over 2x plus 7. Okay, I'm going to add 5. Well, first, let's just multiply by the reciprocal. So on this one, I am going to get a different color to show you what I'm doing. I'm going to multiply this by 2/3. Okay, that's because this ultimately ends up being 1. But I still have to multiply the 7 by 2/3 also. And then I have to multiply the other side by 2/3 because whatever we do to one side in algebra, we do to the other. So I've already said this equals 1. Well, now 2/3 times 1, I'm going to do, if I put that over 1, 7 times 2 is 14. 14 over 3. Okay. So we're going to have x plus 14 over 3. Okay, then I'm going to come over here and I'm going to do the multiplication as well. Well, 2/3 times 3 is 6/3, so that's 2x. Then 2/3 times a negative 5 is going to be a negative 10 over 3. Okay, now I'm going to add, and I'm just going to do these one step at a time because when it comes to fractions, people get really confused. I'm going to add 10/3. And you'll see why this is easier in just a moment. So this will equal, we'll get rid of this, those cancel out. And then you'll have x, and that's 24 over 3, which is 8. Okay, then we're going to subtract a x. So x just equals 8. So I still have to check this. So I'm going to go ahead and check it by using this, because all this is a simplified version of this equation up here. So I'm going to put 3 times 8 minus 5 equals 1.5 times 8 plus 7. Okay, 3 times 8 is 24 minus 5 equals 19. 1.5 times 8 is 12 plus 7 is 19. So they checked. So we did both correctly, and that actually ends the review and preview for lesson 1.1.3. Now, please remember, if you enjoyed this video, please subscribe. there's no obligation, but eventually I would like to monetize this channel. And the more subscribers I have, the closer I get. Also, don't forget, if you have questions, you can leave questions in the comments and I will get back to you and help you out. Just because I'm online and on YouTube doesn't mean I'm not accessible. I am still a teacher. I still want to see you guys succeed. So just let me know. And thanks again for watching, and we'll see you on the next video. Have a great one.